Hi everyone, my name is Tovio Roberts, and this is another installment of Latent Topics in Data Science. Today we're going to be looking at a dataset from Data Europa EU. It's a COVID-19 dataset, and this is actually a lecture that we have been doing for the last number of months in our premium prep course, and we're retiring it this round. We're actually going to switch over to using the Johns Hopkins data for COVID within the United States when we give this Pandas lecture. So, as a good retirement, I figured I would just stream it here, and then it'll exist in perpetuity, and it'll be a good reference point if you're trying to learn pandas or some rudiments of pandas. We're not going to be doing pandas very deeply here. We're just going to be using it to kind of seed the idea of data exploration. So why don't we go ahead and get started. I'm here in a Jupyter notebook, and I'm running this locally. If you are new to Jupyter notebooks, they just happen to be pretty convenient sometimes for exploring data. Everybody kind of has different ways they go about doing this. Some people will explore data in their text editor and a terminal. I'll usually take a first quick pass using a Jupyter notebook so I can, make some quick plots and visualize them all in one place, dump out a PDF, hand it off to somebody if they're interested in some initial statistics and visualizations. We're essentially going to do something like that here. And we'll do a quick walkthrough of some things in Pandas while we do it. So one nice thing about Jupyter Notebooks is you can write Markdown in here. So you can have text that renders in a way that is pretty nice. So I'm just going to call this Exploring the EU COVID-19 dataset using Pandas, and I have a link to the dataset itself. Oh, actually, first, let me just link out to the dataset. It's here. Find the dataset at this location, Data Europa EU, COVID-19 coronavirus data. Now, what I could do, one nice thing about Markdown, is I could make this, just a link in Markdown, and so it'll render kind of nicely. I won't have this big URL here. So let's do COVID-19 data from data.europa.eu. Oh, I did that backward. And there, that should render nicely. COVID-19 data from Data Europa EU. So let's just open that up and take a look at it. So there's a good description here. Dataset contains the latest available public data, etc. Gives a little bit of background, and down here under resources, there is the COVID-19 cases worldwide, which is what we're going to grab. This should also, I think last time I looked at this, the last time data was added was, or the first time was 2/27, and it looks like, no, that is not the update date. Okay, well, either way, we're going to see the most recent date that this has been updated. It's probably yesterday. So we'll go ahead and download this. And I'm going to throw it into a directory where I am keeping this, and I'll sync all of this to GitHub in a bit. So as I said, I've been doing this lecture. I've done this lecture, I think 3 classes now, and we're switching to a different data set. So I'm going to go ahead and retire this. So today is the 23rd, and go ahead and put that in there. So we've got our data now. I just downloaded it directly, and I'm going to import it into this notebook. Okay, so starting off, I'll go ahead and toggle the header, give us a little more space to look at this. I'm going to use Pandas, and I'm just going to go through my imports really quick. So I'm going to import Pandas as PD, import matplotlib.pyplot as PLT. These are all kind of the standard names for these things. I'm also going to import some stuff for matplotlib, matplotlib.patches as mpatches, and these are just little utilities I'm going to use to clean up my plots when I make them, as ticker, and I'm going to import IO. Okay, so all of that should import. And the first thing I'm going to do is I'm going to make a data frame. And you're going to see this convention, you know, df gets something. And in this case, I'm going to do pandas.read CSV because we downloaded a CSV file. And I'm going to get the name of that. So what I might do here is let me just look at where we are in my file system. And then I'm going to list directories, right? And notice we have this data directory. I'm going to do ls data. And these are all the data sets with the dates where when I downloaded them. So 2020, 723, data Europa EU, COVID-19, data CSV, that's what we want. And I'm just going to throw that in there. And hopefully that'll just read in. Oh, what's the issue there? Interesting. Might be something a little corrupted here. Oh, you know what? I did not copy .csv. Oh, huh. Nice. Okay, yeah. I just pasted in the URL. I didn't actually copy the file name as I meant to. Ooh. File not found error. Well, that makes sense because it is in the data directory. There we go. All right. So I have this copied in, and I can now look at it. df.head, and let's look at the top 5. Actually, let's look at the top 10 entries. And let's talk about it. Okay. So notice here, there's a number of columns that we can look at. And these are all, some of these are going to be useful to us, others are not. Really, it's going to be pretty straightforward, this data. One nice thing about this data set is it's relatively clean. There are some little anomalies in it, and every time I look at it, you know, a couple anomalies have been fixed, and other times, not at all, as it turns out. So, you know, let's just look at these. Date rep, which is date reported. This is in the European format, 23/7/2020, so that's July 23rd, 2020. That is the most recent day that Afghanistan reported. 7/23, and today is the 23rd. So as you can see, this data is ostensibly up to date, but we don't want to get, well, we want to be careful in the way we think about this data. as with any data, you want to take a critical lens and start thinking about it as being prone to idiosyncrasies of how it was reported, if that makes sense. So, if you're following the news or paying attention to epidemiologists right now in the US, you might be seeing a lot of changes in the way our data is being reported. And you can imagine every country in this list, 200 something countries, is going to have a different set of protocols for reporting data. And that's part of the reality of this data set, which is going to mean that we need to think critically about how we look at the plots that we generate. We have to think critically about statistics we might garner from this data, things like that. So at any rate, we've got date reported, day, month, year. Day, month, year here is provided so that we've got these actual, integer values that we can deal with. We can arrange them as 7/23/2020 if we want, as opposed to using this 23/7/2020. We can filter by month. We can filter, well, obviously by year, but all the years in here should be 2020. Filter by month and day, however we want to do that. And then we've got daily reported cases. And this is the nature of this data. We've got cases and we've got deaths. So we can see here that reported to EU data, Afghanistan stated there's 188 cases, new cases for the 23rd of July, and 21 deaths. And, we could look at this day by day, and we can get an idea of the progression of this disease, either by cases reported or by deaths. But again, this is reported, right? And there are idiosyncrasies about how a country reports. A number of countries that report don't report on Sundays, and you will actually see that in the plots when we generate them. This is going. These rows are are in alphabetical order by country, going from the most recent date to the oldest date. So we're seeing Afghanistan here. And there's a little bit of redundancy, right? Afghanistan will always have a GeoID of AF, a country territory code of AFG, and population of a 2019 population of what is this? Of 38 million, and always have a continent of Asia. And we can look at this, the cumulative number for 14 cases of COVID-19 cases per 100,000. This is something that we might be able to use to get a sense of the rate, but we're not going to. We're actually going to leave that data point aside. We're only going to use the date rep, cases, deaths, and countries and population data. And I'm going to trim the rest of all of this out. So let's take a look at how many reports have actually been made. And when we're doing this, we're basically going to be taking a first look. That's how we want to think about this. This is a first look at our data. So how many rows are in the data? Looks like there's 31,500 rows. And, there are a couple other little utility functions in Pandas that we'll think about, right? So there's this info method. So the info on the data frame. Why don't we take a look at this? And let me just zoom this out, make it look a little nicer. So this is telling us the data type for each of our columns, each of our features up here. So date rep is an object which for our purposes here is a string. And day, month, year, those are all integers, 64-bit integers. Cases, deaths, also 64-bit integers. Countries and territories are strings. Kind of interesting here, the population data is reported as a float. And I'm assuming that's because there is some kind of null value in there, in somewhere reported for population, and you know, kind of a not a number type of thing. And so we get a null value for not null, but a not a number value for population data, and then that translates when we look at it across everything as a float. And as you can see up here, these numbers are reported. The population is reported as a float number. So that's actually going to be a problem later that we'll take a second and fix. Another, you know, utility function, or not function, but an attribute of a data frame is its shape. And we can see here, again, there's 31,500 or 600 rows, and there are 12 features, as we can see here. So these are all just different ways of thinking about initial, you know, just an initial look at some data. What are the names of the features in our data frame? Well, why don't we find out? I'm going to get just a list of the columns, and I'm going to use the columns attribute on the data frame. I'm casting it to a list just to make it easier to think about when we look at it later, and I'll go ahead and display these columns. So, you know, we've already seen these, but now we could access them one by one, right? We could say calls sub-0, and we get the name of that feature. Okay. There are other kind of utility functions that, you know, I'm going to just point out here. These can be helpful, but you want to be careful. There's the describe method, and this is going to give us some summary stats, right? Mean, standard deviation, the quartiles, the min and the max. But you know, you want to think about this method and ask yourself, does this help us in some way? It turns out that this really doesn't help us in this case, because and this is for a few reasons. If we're thinking about the mean of the day, well, obviously it's, you know, 15 point something, because we've got 31 days in a month. The mean of the month, you know, this looks like somewhere between 2 and 8, right? Or 2 and 7, or 1 and 7. I think earlier reporting was in January. Year, you know, there's a little bit of 2019 reported, mostly 2020. You know, none of this is helpful so far. But then we get to cases, and we might say, oh, well, the mean number of cases reported daily is 481. It might be tempting to say that, but we can't really compare in this way. You know, we've got Afghanistan, we've got Albania, we've got Cameroon, we've got the US, we've got Brazil, we've got all these countries, and they all have different populations. They all are really fundamentally different, right? And they all have different reporting styles, like different ways of reporting the spread of infection. They've got different numbers of days that they've reported, right? And so this number, 481, this doesn't have a meaning that we can state without a lot of ambiguity, right? I think somebody might be tempted to say something to the effect of, well, the average number of cases a day reported worldwide is 481. And that's just not going to be true by this data. So, you know, be careful when you use the describe method. It's going to, you know, it could lead you astray. And, you know, same goes for deaths, right? Same problem as with cases. And then we've got this population data. And again, you might be tempted to say, well, there's a mean of, let's see, 1, 2, 3, 4, 5, 6, 7 of what, 452 or 45.2 million? I think 452 million. No, it's got to be 45.2 million people in, you know, across all the countries. There's an average of that many people across all the countries. There isn't. And again, this is an issue of how many days different countries reported, you know. this is not going to be lined up with anything. So it's not a very helpful number. So let's set aside describe. I showed you df.head up here, which gave us a look into the top 10, the first 10 entries in our data. There's another function, another method here, df.tail. In this case, I'm going to look at the last 10 entries, right? So we've got, it makes sense. We can see, just get an idea here that our data is in order, right? From Afghanistan to Zimbabwe. Now, if I want to access a specific column in the data, a specific feature, there are a couple ways to do that. And I'm going to show both. And I think I end up using both. I might end up using both. I prefer one over the other, honestly. But I'll show you first dot notation. And this is going to be simply df dot whatever the name is of the feature of the column. And in this case, let's just take that first column, date reported, and we'll look at the first 5 entries of that. And this is 723, 722, 721, 720, 719, etc. The other way that we can do this is with bracket notation. This is generally what I prefer to use. And one isn't better than the other. It's just what makes sense for you. So, or what's easier in the context of the thing that you're coding. And note, we just get the same result here. There's nothing really enlightening, nothing different about those two ways of doing that. So we could, we could do the same thing for the cases, right? And let's do df sub cases and get the first 5 entries of that. Okay. So 188, 112, 140, 174, 172. Now, again, in this case, we can use describe, okay? And this is going to get us, again, some summary statistics. We still have to be careful. We've got a whole bunch of different countries. We can't really speak of this mean or standard deviation or really any of these values as being meaningful. Although, interestingly enough, there's a negative value in here for cases reported on a given day. This negative 29,726, 29,726. This, I haven't looked into it, but my assumption is that this is either there was a misreport and then there was a redaction of the number of cases, but I really suspect that this is an error in the data. I'm not entirely sure. It seems, how do I say this? It seems like the more appropriate way to correct the data would be to correct it on prior days. But I could be wrong. There might be some meaning to having a negative value in here. I'm assuming there isn't. We're not going to repair it. But just notice that at least describe here gives us a sense that there's something a little anomalous, or at least something that we wouldn't expect. Okay. So why don't we ask a simple question? Well, how many countries reported? So there's a couple ways I can do this. The first way that I'm going to consider is just using the describe method that we've already used, and this time we're using it on an object. Notice it's giving us a count of this. This is just the row count. There's 210 unique values, and that's probably telling us that there are 210 countries that reported. And notice it's saying the top country that reported is Denmark, and we might be led to believe that they reported the most times with 206 reports. Although if you were to take this notebook and run it, or let's say we re-import the data. This could be a different country. It could be Norway. It could be Germany, because a number of the countries have reported the same amount of times, 206 times, as of today. So, the other way that we can get the count, the number of unique countries that reported would be, why don't we just do this? Why don't we just make a list of the countries, because we're going to use this a little bit later. This is just going to be using the unique method, territories.unique. And, the first thing, I'll just print the length of the countries reported. And then I'm going to say for country, well, I'll do this as let's say print country name for country name in countries reported. And that's just a quick comprehension. And there are 210 countries, and here they are in alphabetical order. So we'll actually use this a little bit later. I should probably put a semicolon after this, just so we're not getting those that none output that we were just seeing. Okay. All right. So, again, this is just a quick exploration of the data before we get to doing some visualization. Something to consider here. If you're, I'm assuming if you're watching this, you have some relative familiarity with Python. You might be familiar with list slicing. There's also slicing in Python data frames. So here I'm going to get from the 5th row through the 14th row displayed. I could do the same thing for, let's say, 2005 through 2015, right? And then we're looking at Azerbaijan. This might come in handy depending on what you're doing. I'm just showing, some aspects, some quick rudimentary things about pandas. Okay, so let's start thinking about this a little bit more. Just gonna give us some space to work, and let's talk masking and filtering. So I'm going to limit our data set. I'm going to make a subset of the data that is just the US days reported, and the rows that are relevant to the US. So I'm going to talk about this in terms of being a mask, and I'm going to build a mask where the countries and territories are equal to this string United States of America. And if I look at this mask, this is giving a report of false or true for every given row, right? So this is sort of something that's going to give us a Boolean expression that we can then use to mask the rows and build from this a data frame that is a subset of only those rows where countries and territories equals United States of America. So how might we do this? Well, we could say, I'm just going to make a new data frame. Well, it's not new, it's going to be a subset, but I can take this mask from up there, US mask, and if I look at this now, this is only going to be US. So it looks like on the 23rd, according to this data set, about 69,000 new cases were reported. Now, notice how I'm doing this here. I'm creating a mask, and then I'm creating this subset. By using the mask, I could just copy this whole thing, and this is normally how we write this. I would probably just do this like this. But I just wanted to demonstrate that there is sort of this interim thing happening, right? So here's the mask, and the mask is sort of acts as a a df sub mask is going to yield a subset according to the true values in that mask. And of course, that just works how we'd expect it to. So how many days? Why don't we answer this question? How many days did the U.S. report? 206. So that's less than what was it above Denmark that was 210 or something like that. I don't actually remember. Why don't we just take a quick look? Oh, no, 206 as well. Okay, so Denmark reported 206. So, you know, we've reported it as many times as any other country in this data set. We might ask a question, how many cases have been reported in the US? And that's easy enough. We can say the sum of the cases, because remember, these are cases reported daily. We can just take the sum across all the rows, and that looks like 3,970,906 as of the 23rd of July. Okay. And we might ask how many deaths, and you know, easy enough. I'll just copy the same thing and make that a little bit bigger. 143,000. Okay. We might also ask, what is the US population? Easy enough. You know, we can just say df US. I believe it's population data. Is it 2020? No, it's 2019. And notice we're getting all of these rows because it's, you know, this is not going to be different across any of the rows. And we're looking at about, what is that, 330 million. Okay. So easy, right? This is all just the initial look at this data. So let's get into some visualization. And, you know, I'm going to have a up for the repo for this notebook. I'll fill in, you know, some notes, and it'll be a little nicer to read through. You know, we're going to visualize this data set. We're going to make a couple plots using matplotlib, and we're going to keep it simple. I'm going to veer a little away from some best practices that might make the code for the plots look better, just to try to make them a little more understandable. So the first thing to think about, well, what kind of plots do we want? I'm going to make two types. I'm going to make a cumulative plot for the cases, right, where we can see sort of that growth curve. You know, keep in mind that if we're thinking epidemiological model, we don't have a line for recovered here. So we're only reporting cases and deaths, and we'll do that in two ways. We'll report daily cases and deaths, and we'll report, or we'll visualize daily cases and death, and we'll visualize the cumulative cases and deaths. So with that in mind, we might need something like a cumulative function. And I'm just going to write that really quick. Very easy little function to write. So I'm going to pass in a list in order of the data and of the reporting per day. And I'm just going to do a simple accumulator here. So the output is going to be this collector, and then I'm going to have an accumulator that starts at 0. And I'm going to say for each number in whatever list is passed in, the accumulator is going to be incremented by the number, and we're going to append each of those accumulations into the output and then return the output. So keep in mind that in our data set, if we look at this, this is going from most recent to, you know, in order of the rows, it's going from most recent to oldest. So whatever we pass in here, we're going to have to make sure that we're going from oldest to most recent if we want to have data that's a little more meaningful. Otherwise, we're going to start with today and add yesterday to it and then add the day before. We actually want to start with the first reported day, add the second reported day, etc. Before we go on, though, let me just test this function. You know, it's easy enough to make a small error, and I'll just make sure it's doing what I expect. Oh, it's not. Oh, because I didn't run the cell. There we go. So this makes sense. 1 plus 2 is 3. 2 plus 3, 1, 3, 6. So 3 plus 3 is 6. 6 plus 4 is 10, and on. So let's get to our plotting function. I'm going to call this plot cases and deaths. And I'm going to pass in a data frame, and I'll just call this df to check. I'm going to pass in a country. We're going to make a single plot for each country, and we're going to set a flag for cumulative or not. So we're going to have, by default, it will be the daily cases reported, and otherwise it'll be the cumulative plot. Okay. So from there, I am going to create a subset of the data frame, and this is just going to be that data frame that we're checking, and then I'll just go ahead and, well, I'll just type it out. It's fine. It's a great idea to copy and paste, but I'll just type this out again so that you see the mask being written. So notice we're creating the subset by country with this Boolean mask that is limiting countries and territories to the country that we pass in. Okay, so here's the data frame, here's the country we're passing in, and now we've got a data frame to use. So to make this a little bit easy to pick apart, and you know, if you want to take this and reuse it, I'm going to take our data and I'm going to put it into lists. So I'm going to cast some things to lists here. I'm going to cast the cases in the country, the deaths in the country, and the dates in the country. I'm going to make these into lists. And when I do this, I'm also going to reverse them. Remember, our data is in the wrong order for what we want to see. So df country sub cases, and then I can go ahead and reverse this simply with this slice notation, : -1. So we're just going to start at the other end and include all of it. Most of this, well, this is all going to be essentially the same snippet. So I'll just paste those in, and I'll change cases to deaths here, and dates, changes to date represented. So that should give us our starting point. So remember before when I mentioned that that float value in our population data. It turns out that somewhere in the population data there is a there are countries that don't have 2019 reported population data, and so we will end up throwing an error if we try to put non-existent data into, or if we try to calculate a percentage of the population infected, if we're trying to put some number over not a number, some string not a number, we're not going to be able to do that. So the first thing I'm going to do is I'm going to correct the population not a number issue, which we will run into. So I'll say the string, and I'll just I'm going to use kind of a boneheaded way of grabbing the max population, or the population. If the string here, if this equals not a number, then our country population is going to be not in the data set. And otherwise, we have a good value here. So I'll just take that same little snippet right here, right there. So that, yeah. Oh, no, it's there. All right. And I'll just take this value and I'll just take this value and I'm going to cast it to an int because I think a population being reported as a float is a little nonsensical. So I'm just going to make it into an integer. Okay. So we're well on our way. Now we want to consider whether or not we want a cumulative plot or not. And I'm going to do this more than once. I'm going to ask, well, are we considering a cumulative plot? And I don't actually have to put double equals true here. I can just do if cumulative. And I'm going to say cases country. This is going to use that cumulate function that we wrote a little earlier. And I'm going to update cases country and also deaths country to be the cumulative values for both the cases and the deaths. So there we go. And I'm going to put a few little bells and whistles on the plot, on the plots that we're making here. You know, I'm going to report the max number of deaths. And, you know, this is nice because this value is going to be reusable, whether or not it's the cumulative or the daily reported cases. So max deaths, then max cases is going to be the max cases in the country. Notice this is going to mean something different. This, you know, max deaths for the non-cumulative is going to be the top deaths reported for any given day. And the max deaths for the cumulative plot is going to be the total number of deaths. So it's serving two purposes here. All right, so let's also make well, let's think about this. Yeah, let's go ahead and I'm just going to grab this again, and I could condense this a little bit, but I'm not going to. I'm just going to kind of keep it split out this way. If the country in question has a not a number, then why don't we? Well, this is actually going to be redundant, isn't it? Well, let's make a new variable called percentage of population, and this is where we're going to report whether or not our well, if we don't have a usable number, we can't report a percentage of it. So that's one thing. And then actually, I think I can I'll just get rid of this up here. It's a bit redundant, but I'll keep this. Yeah. So country population, and then we'll grab this percentage of population, and we'll make it the percentage of the population, right? And I'll go ahead and make this a string off the bat, and I'm going to use dot format here. I usually use f strings, but I find this to be a slightly nicer way to write this. Dot format the max cases over the country population. So simple enough. This is just going to be the percentage of the population formatted to 2 decimal points. Okay. Now we can just create the figure. So now we're actually going to write, we're going to create the visualization. So plt.figure, and I'm going to create the axis where we add a subplot fig.add subplot 111, and we're going to plot a couple things here. We're going to plot the dates, and those are going to be along the x-axis, and we're going to plot the cases, and we're going to make those blue. Then we're going to do the same thing on the same plot except with deaths, and we're going to make that color red. Okay. So that's essentially going to be our plot. If I did plt.show right now, we should be able to see something. In fact, why don't I do that? And let's just plot the cases in Brazil, just to see where we're at with this. So plot cases deaths on the data frame from Brazil, and we'll say cumulative is true. So unless, oh, there we go. Okay, yeah. So this is a plot. It's maybe not the most readable plot in its present form, but you know, it is a plot. We don't have any annotation. We don't have a title. We don't have any of those things. It's you always want to have a title and good annotation on all of this. So why don't we fill in those kinds of things? All right. So all right. So let's make a y label. So ax.set the y label, and let's just call this counts. Let's set the x label. We'll make this a little nicer. We'll say up to, and we'll, oops, up to the date in there, and the last value of the date that's in there. And let's put the source. I think that's always something you should do. Data europa.eu, and I think, so let's just see how that looks. Notice we have a little annotation along the x-axis. Okay, so let's also do something here that might almost make it readable. These dates, these are actually dates that are smushed all over each other down here. Let's do something about that. Let's say set the tick labels for the dates, and let's just rotate them. This is going to almost get us something that's almost readable, but not at all, actually. It's just going to make it unreadable in a different way. So let's take a look at that. Yeah, same. It's just a big smear because there are so many of them. We're going to do something about that. And this is kind of a little bit of a boneheaded way to do it, but it's going to be understandable, and we'll you know, see this as at least a stopgap for having readable dates. So we're first going to get the number of dates that are reported, and we're going to say if there's less than 11 dates reported, we'll leave it as it is. Otherwise, if there's more than 10 dates and less than 30, let's do let's modify n, and we'll just divide that by 3, and I'm going to start copy pasting. So then we can go from greater than 30, actually greater than or equal to 30, and less than 60. Then we'll grab this, and instead we'll divide it by 6, right? And following that same pattern, we'll just say less than or equal to 60, and n is less than, let's just do 100 instead of 90, and we'll divide this by 9. And then otherwise, n is going to be divided by 12. Let's do 12. Okay. And here we'll go ahead and modify the tick labels. And we'll do that with a quick, so, you know, first I'm just going to check if the dates in the country are greater than 10. This is the only case where we need to modify the tick labels. I'm going to say label.setVisible. So this is for, you know, certain, we're going to set invisible all but some of the labels. So l.setVisible, I'm going to set this to false for the location of the label in the enumeration of those x-axis tick labels. And that looks correct if the modulus of n is not equal to 0. So let's see how that works. And that's not too bad. We get a little bit of a, you know, double date here because we're still putting the last date on there, but I think that's fine. I think I'm comfortable with this. I think we can go forward with that. And yeah, notice these are still the European form of the date, which nothing wrong with that, but you know, look at this. This is 12/31/2019 through 7/23/2020. It's usable in its present form. We could make it a little cleaner, but let's just add other annotations to this to get it up to speed. Okay. So if you noticed when I accessed the United States before, there were underscores in the name of the United States, and I'm going to go ahead and just replace all of our underscores with spaces, just because we can, you know, just to give you a sense that you can do that. And then I'm going to make a superior title where we have the country. And so this is going to be the country name that we just made. And they reported, well, they reported as many rows as there are in the data. They reported that many days, and this is the COVID-19 data. And I'm just going to put a font size in here that I know is going to work well for what we want. And that's just going to be font size 14. And we'll do a different font size for the title that we make. So let's make sure that looks okay. Brazil reported 206 days, COVID-19. And wow, they're up to around 68,000, 65,000, something like that as well. Okay, so what can we do next? Well, we want to report, we want to visualize, we want to annotate a little differently if this is cumulative or not. So I'm going to say if cumulative is false, then the title here is going to be, so if this is not the cumulative plot, the max cases in 1 day is going to be whatever that max cases is. The max deaths in 1 day is going to be whatever the max deaths are. And the population of the country, well, we have this. We just have country population. And notice in the event that this is unreported, if it's not a number, we'll still have it, right? We'll have a string that will work for our purposes. And that'll be, I think it's just not reported is what we called that, right? Population not reported. Somewhere up here. A not in dataset, that's what we called it. Okay, so think that's working. Population, country population. Oh, that's needs a little bit more. And Okay, so otherwise, if it is the cumulative plot, then I'm going to do plt.title, and we'll say the total cases is whatever max cases is, right? As I said before. And then the percentage of the population is now what we'll report here. And we'll say percentage of population, which we calculated above. And we're going to do total deaths as well. And we'll just call this, we call this max deaths. So what we could do here, we also want to make a key. Well, first off, let's just make sure that this is doing what we expect. Notice max cases, max deaths, all that. And what else? Oh, we need to check if the other one is working okay. And it looks like it is. Total cases, population, percent population, and total deaths. So that's looking all right. We also want to make a key here. And I'm going to do that within this structure. So I'm going to say for our blue line, this is where we're calling out to that mpatches that I called up, that I imported earlier. So the color of this is going to be blue, lowercase blue, that is. And it's going to have a label of daily cases. And then we're going to do the same thing for red. So red is going to get red, and this is daily deaths. And then I'm just going to copy this, and obviously there's a nicer way to do this. You could do this slightly more compact. In this case, instead of daily cases, it could just be cumulative cases, and daily deaths would be cumulative deaths. So now how would we make this different? Easy enough. Why don't I just take this and I'll pull it out of there, and instead of having that double, let's say if cumulative, then let's say plot type, let's just call it plot type, gets cumulative else plot type gets daily. And we'll go ahead and make this an F string, and we'll just put the plot type in there. And we'll do the same for deaths. So that should work. And then we want to just set up the legend for this, and hopefully there are no errors. Let's find out. Nope. Okay, so cumulative cases, cumulative deaths. Let's test the other one. Daily cases, daily deaths, and that's working how we'd expect it to. Now, I'm going to preemptively solve a problem that you might notice. It's not really a problem, it's more of an aesthetic issue. If this number is high enough, well, why don't we do United States of America. Oh, I guess let's do the cumulative version of this. Oh, interesting. I expected this to have a multiplier on it, but it does not. There's a chance that some of the plots will, and I'm just going to preemptively solve that so that we don't run into any issues with that later. Okay. All right. So we can throw in any number of countries. Let's look at Argentina. The cumulative, right? Total cases, 136,000. Let's look at Serbia. And let's look at let's look at cumulative for Serbia. Total cases, 22,000. So you might be thinking, well, we can generate plots for every country, and you're correct. So why don't we just do that? Easy enough to do. If you remember, we set up this for country name in the unique data frame column countries and territories. We could just reuse what we had above. I think we just had country list or country names or something like that. But we can just do this again. I'll just do that. And we'll plot the cases and deaths for the data frame for each country name. And we'll do cumulative is false. And we'll do the same thing for cumulative is true. And if I run this, it's going to take a while, quite a while to run, but this should plot all of our countries. Let's see if there are any errors that pop up from, just anything. Let's find out. And this gets interesting, right? So we can see, we can almost get a sense if we knew more of what was happening behind the scenes in terms of reporting, in terms of day of the week, in terms of different changes, because there's some kind of periodicity, or seemingly, in Albania, and maybe what I'm assuming here is that there are very low numbers of cases reported on Sundays, and maybe there's a holiday right here. This is not an uncommon pattern to see. And then we've got some anomalies, right? So we've got in Algeria, we've got this massive, this might be where that, oh no, this isn't that massive. This is only around 500. So it looks like there's, excuse me, I'm misspeaking. This looks like a 0, and this looks like a 0. So what I'm imagining here is these are holidays, right? And I don't know that, but they very well could be. And this is the kind of thing where if you see certain things in a signal, you investigate those things, and you dig up more information, and you try to get a sense as to what happened there. Andorra, it looks like there was one day where around 80 cases, 79 cases were reported. And we get this kind of interesting cumulative plot where we jump up and then boom, we jump up a little bit more and we keep going. Again, we have periodicity when we look at Angola. We have some countries that essentially have, 0 cases. Max cases in one day, 2 max deaths in one day, 0, right? So, we can see that a lot of different places are performing differently. Argentina, this looks like Sundays, holidays, so we can, we can see a lot of different types of signals. And, you might be tempted to say, well, let's compare Belarus to Belgium. And it is a temptation. It's an understandable temptation. But you want to be very careful when you do this because, can you compare two countries that have very different reporting on this infection. And, you know, you could say something like, well, it kind of looks like in terms of cases, Belarus has, you know, Belarus and Belgium are doing very similarly, but you just want to be careful, right? Because there might be underreporting in one of these countries. The criteria that they use to report might be different, and it's going to be more helpful ultimately to look within the country in light of their diagnostic approaches, or at least that's my opinion. So I'd be hesitant to, you know, to extrapolate too far. And here we've got one of those anomalous values. Here's a -200 cases reported in Benin. And, you know, we don't know exactly what that means, but it's there, and it's a little bit of anomaly. And it's interesting for no other reason than that at this point, right? We could dig into it, find out what it means, or if it is some kind of error in the data. Here we've got Bermuda. This is a different signal, right? And this has fairly low counts. So possibly what we're seeing is that the testing center was open periodically and closed on other days. That's offhand an explanation. I don't know if that's true. Again, you have to dig in, learn the domain to be able to say things like that. So, yeah. So this will live in a GitHub repository. Feel free to grab this, adapt it for your own projects, use it to, you know, expound on it, and using the same data. At a later date, I might go through the Johns Hopkins state data for COVID for the United States. I think that's really interesting data. It's got recovery as well as a reported metric. So I think you can get a better sense if you're comparing it to an SIR model. You know, how do past projections look against this, against the Johns Hopkins data? You can also, you know, really try to fit that model and determine the parameters from the model. And those types of questions are interesting. So, yeah, I think that's it for me for today. You know, this is just getting your feet wet in data exploration. It's not hard. And, you know, there are a lot of resources out there. I often will recommend the Kaggle Pandas. Oh, it was the first thing that came up. The Kaggle Pandas tutorial. I think this does a pretty great job, and it has you working with a real data set. So if you want to get your feet wet in Pandas, I would say go here and start there, and then maybe dig into the repository. I'll put the links to the repository for this into the description, and I'll put links to Kaggle and the EU dataset that I used as well. So thanks so much, everybody, for tuning in, and I will see some of you in class, and others, you know, watch out for more videos coming up.